Whew. Alright everybody, so here we are and let's continue from here on, and I hope I'm audible and all, everything's clear. Yeah, definitely I'm audible. Alrighty, so we were supposed to be talking about all these things right here, mentioned here, so let's just simply go through them one by one. So first of all, we have app.js. This simply handles all the code related to backend, and then we have some modules. Main.js simply handles the main stuff, exactly how the things work and all, related to the kind of UI and all. So ultimately it does the, access the buttons and just simply initializes the UI and just gets the other stuff done. And lastly, I have modules, and inside that I have a jar. So this simply makes the request, create room and destroy room. Then I have constants, they are gonna be just simply for the types and all. After that I have state. Again, it will just manage the states depending on the need. UI utils simply handles UI utils related stuff, UI related stuff. WebRTC simply handles WebRTC related functions. And lastly, we have WebSocket, just simply handles WebSocket related functions and all. So that much it I don't know why, but it's crazy to just continue with this, but never mind, let's do that. Why not? So first of all, we have connections, that's fine. We have rooms, that's also fine. We have port number and all, that's pretty much interesting stuff. This particular route is mainly used for rendering the file, so we don't really need to worry about it. Then we have this create a room and destroy room. So the room is actually going to be created, and that's all. We don't really need to worry about it, especially when it comes to the room. So how many things we have inside the room? Inside the room we will have a room name, peer 1, peer 2. These are the things that we are actually gonna be having. So the room name and all the peers that are actually connected, and that is it. That should be fine. And when we are actually creating the room, so the room should be there. And as for the peer should not be there. A peer need not, peer 1 is definitely gonna be there. So whenever I'm creating the room, so I must be inserting the peer 1 as well. That's what I'm doing here, and that's what should have been done. Okay, so this particular thing is done. And one more thing is that whenever handling the body or getting the body, I'm simply using a request module over here. I'm not using the middleware provided by Express. Rather, I'm just getting the data in chunks, and then I'm simply adding it to the body, and then simply stringifying the body, and at the end of the day parsing the body. So this is how the things are actually happening over here, and overall things are fine. So this is not even something that I need to worry about. Then we have destroy button. This kind of does the same job. It just simply destroys that. Then we have WebSocket server, and it just simply gets the server WebSocket connection, handles the connection. It just simply says that it got connected, and then extracts the user ID and all. Once they extracted, it simply adds the connection as well. So we do have two things. We have a room and we have the connection. And then on message, close and error, these things are handled over here. And after that I have handle disconnection, handle message. This is the important one. And if we will make sure, we will first of all confirm whether that is a normal server process or WebRTC server process. Once this thing is done, unknown message label, that's fine. If that is a normal server process, so all the things are gonna be happening here. Join room handler, exit room handler. So we will be joining the room if that is a normal server process. We will be even exiting the room if that is a normal server process. When joining the room, what am I doing? When joining the room, I'm just simply gonna be joining that particular room, exit room, and existing peer 1, peer 2. If the room exists, that's great. If the room if the room does not exist, then of course we will not be able to join that. So that's gonna be a failure message. And lastly, we are just simply send WebSocket server message to user. It's too much actually. It's not like it is not understandable, but can't really do anything. I'll have to go through it anyhow. Send WebSocket server to the user. Send WebSockets message to user. Send WebSocket message to user. What does this do? Okay, just simply used for sending the WebSocket message. And join room handler, exit room handler, WebRTC server processing. It turns out I had better just simply directly start working on it, honestly. This is the only way is left for me right now. Most of the things are okay, I've gone through them many times, so Do I really need to just go through them over and over? Am I facing some kind of network issue? Let me check first of all. First of all, it's gonna be something because going through the whole coding and explaining everything and all, that's gonna be something quite a lot, definitely quite a lot. But there are two things. I have to rebuild this project. It's better to just simply go through it. But even before going through it, let's do one thing: run it and see whether everything's worked correctly or not. So npm just simply start, should be starting it, and once it is actually started, then I can actually come here, localhost 8080. Yeah, quite a lot. Let me turn on the dark mode right now, just like this, and one more page I will have with the same address. So ultimately 2 users are gonna be connected right now. Not only that, I will have one more kind of browser, and then I'll keep it on the left side, kind of not even a browser, just a browser page. That should be fine. Okay, let's simply create the room. So secret room is gonna be created. So first of all, we are creating the room. So room is created over here. Same is gonna be happening here as well. I'm gonna be, once the room is created, I will be joining the room. So this is how I have joined the room and all. Okay, once this particular thing is done, then even I'm being notified here that okay, you have joined the room and all. So this much is done. Okay, and let's even go through the code of that, exactly how these things are actually happening. So okay, when I'm gonna be, okay, never mind, let's simply go through the code first of all. I mean this particular functionality. So we are creating the PC, and one more thing, we have to go to web RTC, not even web RTC, chrome / web RTC internals over here, and I will be able to check whether things are actually happening the way I expect them to happen or not. So this is actually coming from ChatGPT. Never mind, I'm not even worried about it. So a user had left your room. Not really, I'm gonna be joining the room. So join the secret room. You have joined the room right now. Here we are. And next, as soon as I create the peer connection, then something should be changing over here. This is the peer connection that I have got. ICE connection state is new, connecting state is new, signaling state is new, ICE candidate pair, that is nothing. It does not really have any property, and at the end of the day, kind of I don't really have any data. So let's create the data channel. As soon as I added the data channel, so the data channel got created. It just simply has the label called top secret room. This is the label that I provided it, and some properties, configurations, ordered false and max retries 0, as simple as that. And on negotiation needed. On negotiation needed mainly runs whenever something changes in the peer connection. Right now, offer got data channel got created, so it just got triggered and all. Okay, let's simply create the offer, and as soon as I created the offer, so create offer, this is the object that I'm getting over here. Kind of offer got created, but offer is still in this space, like it got created, but it hasn't been set yet. This is the info about the offer, and here I have this media type that I just talked about earlier in the previous slide. An application, UDP, DTLS, SCTP. So SCTP is mainly used for sending the text messages and all. DTLS is mainly for encrypting, if I'm not wrong. I will have to know more about it. Having said that, I'm gonna be UDP is going to be used, DTLS, and SCTP is gonna be used. WebRTC channel, data channel, of course, that's the one we are focusing on, and some other stuff is here. Some other stuff in the sense max, mid, setup, fingerprint, ICE options, present. Okay, then there is something called ICE UFrag. This is mainly used for user fragments, if I'm not wrong, but having said that, I do need to read more about it. Okay, once the offer got created, then I can just simply set the local description. As soon as I set the local description, that simply means that ICE candidates will start gathered by the browser. So let's even set that. Once I've done that, so here these are the ICE candidates that I've actually got. You can just have a look at them. Some of them are from the host side, 3 of them are from the host side. These are from the host side, and just a sec. Yeah, here we are. So these 3 are from the host side, these 2 are from the Eastern server side, and this one is the ICE new. This is the transport, this is not the ICE candidate. So ultimately these are the things that we have over here. These are the candidates that we actually have, including this one. Okay, and after that, what else? Once the ICE candidates got created, now I have the ICE candidates over here. That simply means I can send all these ICE candidates to the other peer, and almost everything else is kind of okay. So let's simply send to the other peer. So offer is sent. Now wait for an answer. So I've sent these candidates to kind of the offer to the other peer. Having said that, I got the candidates and I just simply added those candidates in an array, as simple as that. I haven't even sent the candidates because there is no peer connection object. So I will create a peer connection object over here. Once this got created, so I will be getting the information related to peer connection. A second peer connection, registered data channel. I registered the data channel. Once the data channel is actually here, now I can set the remote offer. I mean remote description. I will be able to set the remote description mainly because I have the offer from the peer 1 side. If I just simply click on this, remote description will be set, and signaling state is gonna be new, and it is just simply telling me that have remote offer. If you go to the previous one, it is simply saying that have local offer. This is gonna be all about the signaling state, that is have a local offer, and over here it is simply telling me have a remote offer. Okay, not only this, this is the certificate they are automatically created. So in order to kind of encrypt the data in the right way and decrypt the data the right way, we need the certificates, and these certificates are automatically created. So whenever you are creating a data channel, the certificates, they are being created, and as soon as you just send the offer here, once you created the data channel, then you are sending the offer as well. So kind of data channel is coming along with that. So the certificate is available on this side as well. If I just have a look at this over here, you are getting the same certificate. And if I have a look at this over here, CF97. Okay, the certificates are different, but at the end they are the ones that are gonna be used for decrypting and encrypting the ones the data. Alrighty, and then I'm gonna be creating my answer. Once my answer is created, I will be setting the local description. As soon as I set the local description, my new candidates will be created, and once I've got those candidates over here, these are the candidates that I've got. Now I can just simply send my answer. Not only send my answer, once I send my answer, so remote description will be set. I will I can actually set I can actually send the ICE candidate. So let me send the answer. So answer got sent, and right now I can actually send my ICE candidate. So ICE candidates are actually sent to the peer 1 side. So let's go to the peer 1 side over here. Once ICE candidates actually are set over here, so I'm just simply getting this information over here that added ICE candidates to temp buffer. Like I sent the ICE candidates from there, and the ICE candidates are received over here, and they are even set in a kind of array. I can create my ICE candidates here as well on the peer 1 side. I never I created them actually. Now using this I can actually send them. So send your ICE candidates to peer 2. So using this I can just simply send them. Once they are sent, then if I go to peer 1 side, they're just simply saying that I added ICE candidate to your peer connection. So all the ICE candidates that I actually sent to peer 1 side, they are added to the peer connection. And right now the last thing is that set remote description. As soon as I set the remote description, ICE candidates are gonna be added. Having said that, if once you set the local description, at that time ICE candidates are generated, and once only when you remote description is set, after that you can just simply add the ICE candidates. So once I've done that, ICE candidates are actually added. Right now the state is actually connected, and that's it. We don't really need to worry about it. The same thing is gonna be here. It is just simply saying that both the users are connected via WebRTC. I can just simply send the message over here, and the message are gonna be available here as well. Hi there, how are you and all. And again, both of them are not sending or talking to each other using WebSocket, rather they are talking to each other using WebRTC data channel. Okay, so this is how the things are actually happening. Having said that, I do need to dig deeper into it. So let's make it like this. Let's set a timer in the sense timer for an hour, not more than that, because of course I cannot really give I have to work on other things too. So I'm gonna be giving it 1 hour, and in this 1 hour period I will be explaining each and everything about the code and all, and exactly why the things are happening. We will be coming back here, we will be going through the stuff, how the things are actually going on, and this is how we will get the things done, okay, from the beginning. So let's simply get this thing started, and for that particular thing, that's fine. Let's open VS Code and let's start it from here. So let's close everything. First of all, I'm gonna be talking about the constants.js file. Look, these are the types and why they are used. Whenever you are creating a room, at that time you need to send failure message or success message, right? So these are gonna be just the types for that, so that you can identify on the client side that okay, this is the success message or this is the failure message. How will you identify? These types are gonna be used over there. So ultimately, while sending the response to the client, I will be just adding these types, as simple as that. Similarly, whenever you will destroy the room, you will have response, you will have failure response or you will have success response. At that time, they are gonna be used. Joining room, whenever you will join the room, first of all, while creating the room and while destroying the room, we will use HTTP server. Why? Creating the room is a single kind of, it is not a bi-directional request, single directional, one directional only. Okay, so it is a straightforward one direction request. Ultimately what happens that you send a request to the backend response sends the response to you. That's it. So whenever you are creating the room or you are destroying the room, at that time, that's simple, you are talking to the backend and the job is done. But when you are joining the room, at that time, no doubt you will get the success message or you will get the failure message, depends. Then you will even request the WebSocket server that okay, I want to join the room. So in order to tell the WebSocket server that yeah, this is a request that you want to join the room, you will of course provide the room name and all. At that time, this will be used. You will be just simply sending, adding this type in the payload, so that WebSocket server actually knows that this is the request. And not only that, WebSocket server will be notifying the other user. WebSocket server will send you the response. That's okay. You sent the request to join the room. WebSocket server will be sending you the response back. That response back can be failure response back. That response can be success response. But that WebSocket server or WebSocket signaling server will also be notifying the other user, because there are gonna be two users, right? So you requested, that's okay. You got the success or failure message, that's also okay. But the other user, that user should also be notified that okay, there is a user who actually joined the room. In that case, when notifying that user, at that time you will be adding this type in the payload, that is it, in the data that you send to that particular user, so that that user can check this notified type, the request that it got. If it has the notified type, that simply means that this is the notification for that particular user, so that that user can get informed that another user joined the room and all. This is how the things going on. Then let's talk about the exit. Whenever you exit the room, first of all, you request like okay, I want to exit my room. You must be wondering, okay, I am requesting to exit the room. What about the response? What about the success response? What about the failure response? But the fact is that as soon as you exited the room, you are out of the WebSocket. As simple as like you stop the whole process. And once you stop the whole process, where will you get your success message or failure message? And that is why we don't have this success message and failure message over here. We just simply have the request, and once the request is sent, your whole process, you will be out of the room. You will have exited the room. That means there's no way to get the success or failure message. Exited means exited, right? So that is why we don't have that. And notify, once you exit, we have to notify the other user. That means we have to add the notify type in the payload that is sent to the other user. So we need to do that, and that is why we have it here. Then room disconnection. Suppose by mistake you reloaded the page, or kind of reload the page is gonna be enough, or you closed the browser. What will happen in that case? First of all, you will have to listen for that particular event, like okay, the page is reloaded or something, or page reloaded in the sense the connection will be disconnected, right? So at that time, you don't need to do anything. As soon as you reload the page, you are gone, right? Or you close the browser, you are gone from there. We need to notify the other user that okay, some user actually reloaded the page or disconnected, as simple as that. So we need to notify the other user, and that is why we have this notify type over here. Last but not the least, when we will start working with WebRTC, at that time we will have three things. We will send the offer, and that is why we have the offer type. We will send the answer, so we have answer type. We will also send ICE candidates. Having said that, you can send the ICE candidates one by one. Over here, we will actually send the ICE candidates together. We will save them in an array, and we will send them directly. Depends on you. You can send them one by one. As soon as you get the ICE candidate, you are sending it. You got it, you are sending it. Or you are just simply storing it in an array, and then you are sending it together. Completely your choice. As in this project, I have done the same thing, so I will be just going with the same way, but both the ways exist, so you can go with any one of them. Lastly, we have labels. What are these labels? Look, there are gonna be two types of processes. First of all, you are just working with HTTP server and WebSocket server. So it is like a normal process, normal server process, right? So this is the normal server process. Second thing is that you will actually be integrating WebRTC. So there's gonna be WebRTC process as well. So code related to normal like the WebSocket and normal HTTP server and all, that's gonna be inside normal server process. Again, this is just a type. We will be just checking how we are using it, but just keep in mind. And then we have WebRTC process. This type will mainly be in the WebRTC related payload, because payload means data that you are sending or receiving, right? So at that time you will be adding this particular label. This is the WebRTC process label, this is the normal process label, and that's it, the end. Okay, so the same thing you will have on the this is all about the backend side. Like on the backend side you have the type and you have the labels. Same thing you will be having on the client side, because again you are sending all these things, types or labels, from the backend to the client, right? So on the client side you should have the same types to identify, don't you think so? So that is why we have the same types over here: room created, room destroy, room join. Everything is same, nothing is changed over here, so you don't need to worry about it. Lastly, I do have the labels too over here. Not only that, there are just few colors over here. Why are they here? Just for designing purpose and all. I have red color, green color, orange color, blue colors, send message color, like whenever I send the message to the user, what should be the color of that, receive message color. All these things are completely optional, you can modify them the way you want, but this is how the things go on. Okay, so far so good. Let's continue from here on. Okay, let's talk about the backend that we have. What do we do actually inside the backend? Okay, so backend is pretty simple. In our backend side we just have two things. We have HTTP server, again we have Express and WebSocket, and we have HTTP server. HTTP server is actually using Express, and that's it. Excuse me. Let's continue from here on. So what am I actually doing over here? First of all, don't worry about it, I'm getting the constants from the constant.js, and what do we have? We have types inside that. Then we have WebRTC from WS, again you have to import it. We have Express, simple, easy peasy. HTTP, this is natively available, so you don't need to worry about it. We have connections. Okay, and as for these connections, there are gonna be two things. Let me just keep it like this, and I just had a jalebi a while ago, now I'm gone. Never mind. Let's keep it like this. So inside connections we will have two things. We will have the WebSocket connection and we will have the user ID. Look, the thing is simple. Connections you are creating. Okay, that particular connection will belong to some user. Okay, so if you have a WebSocket connection, that simply means that that particular WebSocket connection should definitely belong to some user, right? And that is why you have the user ID over here. That this is the user ID you have, and this particular WebSocket connection belongs to this particular user ID. That simply means if somehow you got the user ID of the user, you can also get the WebSocket connection of the user. And once you got the WebSocket connection of the user, that simply means you can send the data using that WebSocket connection to that particular user. And this is how things are gonna be going on. Again, once it is actually sent, then on the client side you will be receiving and all, you will be getting the job done. But ultimately what is happening, but one more thing, look, suppose this is your, in the middle, this is your what is this, I mean server. Okay, WebSocket signaling server, call it anything, but this is the server that you have. Then there is peer 1, there is peer 2. Ultimately two users are there, both the users are connected to the same server. Now once they are connected to the same server, so peer 1 will have its own user ID and WebSocket connection. Peer 2 will also have its user ID and WebSocket connection. Now whenever a request comes from the peer 1 side, I'm also going to send the user ID of the peer 1. Then what will happen? Once I receive the user ID of the peer 1, I will be able to find the WebSocket connection of the peer 1. Once I got the WebSocket connection of the peer 1, I will be able to send the data back to the peer 1. Same thing will happen with the peer 2. This is the peer 2, user number 2. I will send the user ID of the user number 2 from the client side, and then I will get the WebSocket connection. Once I got it, I will be able to send the response back and all. Once I'm using the WebSocket connection of peer 2, ultimately user number 2, and I'm sending some data, that data will only go to peer number 2, because I'm using the WebSocket connection of that user. As simple as that. So whoever data, I mean kind of WebSocket connection you will be using, the data will be sent over there only. I hope it does make sense. By the way, let's continue from here on, and then we have room. So what will you have? You will have your room name, and you will have peer 1 and peer 2, and that's the same thing we have here. So let's make it explicitly, clear over here. Inside the rooms, this is again connections is gonna be an array. Why? Because there are gonna be many connections, and that is why it's gonna be like that. Similarly, rooms, there can be many rooms, and when it comes to those rooms, so I will have room name, I will have peer 1, I will have peer 2. Peer 1 in the sense the user ID of the peer 1, peer 2 in the sense the user ID of peer 2. So as soon as connection gets ready, I will be adding the user. First of all, connection will be there, right? So once the user joins the room, connection will automatically set. So that's gonna be user ID, that's gonna be WebSocket connection. Then the user can create the room, the user can join the room. If the user creates the room, that's gonna be set in the peer 1 connection, peer 1. If the user actually joins the room, that will be set to the peer 2. It's simple as that. So this is how things are gonna be going ahead. Alright, then I'm just simply defining the port. It should be simple, easy peasy. Then const app express, this should also be easy peasy. Then app.use express static public. What it does? The thing is that over here I have my public directory, and inside this public directory I have all the code related to the front end. What happens now, once I actually set the public directory as static files, that means it is available globally in the sense from the app.js you can directly access the public and everything inside that, and that's it. You don't really need to worry about it. You don't have to explicitly add the path. Public is directly available in the root folder. So from the root folder you can directly add the access everything inside public, and done. You are pretty much good to go. Again, if suppose you are getting some data from the server side, client side, so if you want to parse that kind of, you are sending the data in the JSON format, and right now if you want to get the data in the body, you can just use this particular middleware app.use express.json and all. Having said that, there is another way, because we are using HTTP, so we can just directly get the request. Because on the server side we mainly get the data. Suppose I'm sending some data from the client side, right? So over here on the server side I will be getting that body data in chunks. So first of all some data will come, then some, then some, then some. This is how the data will keep coming, and once all the data is arrived, I will just simply add it to the body and I will parse that particular data, and that's it. The job will be done. So this does the same thing. You can use it or you can leave it, it's completely up to you, but yeah, I just wanted to share that this kind of does the same thing. Okay, over here if you just go to the root home route, or home route, you are just simply sending the file in the sense process.cwd current working directory plus public index.html. so you are just simply adding the current working directory, and then you are just simply saying that public index. One more thing here, I'm not getting one thing. If I'm actually making this public a static file over here, so what is the use of adding this current working directory over here? Let's check this thing out. This is the doubt that I have. By default it is working, no doubt, I know. If you just simply reload the page, it is definitely working. You are able to see the stuff here, that means you are able to render the stuff. The question is, everything inside public is actually static, that means that is available. If I reload the page I will not get the, oh, am I getting that? Stop it, start it again, reload the page, and turns out yes, I am getting that. Why am I getting it? The question is this. Earlier I was using this path, process.cwd and all, and right now what I'm doing, I'm just simply saying that response.send file, and that's it, slash public slash index.html. and why it actually works, let's see one more time whether it actually works or not. Starting it, reload the page, the second one as well, and it works in both the cases. Why it is working? Simple stuff. At the top over here I'm making the public as a static dir directory. That simply means it is available in the root folder, and from the directly root folder I can access everything inside the public. Just a sec, hang on for a while.